Hello, in this video we're going to look at task 1 of the higher course assignment. This will look at modelling modelling and assembling the parts that we need to start generating some marks. The modelling itself doesn't pick up any marks, but as you can see from task 1A, we can get 6 marks for the orthographic views of the base and the shade part. Now it does give us the option of using top-down and bottom-up. I'm going to use bottom-up modelling purely because it's what students are typically um, more comfortable with. So you will have done more work bottom-up modelling than you have top-down. Both are acceptable, but I think generally you guys find it a little bit easier with bottom-up modelling. If we start to go down and have a look at the data sheets, we can see an exploded view of the shape. What we're looking to model is parts 1, the base, parts 2, the stem, parts 3, the boss, and 4, the lamp. We're provided with these other parts to add in at the assembly stage. So straight on to task 1. Have a little bit of a look at this. All the sizes that are here that we need. Looking at it quickly, I'm thinking that I'd extrude up this elliptical platform before doing a two-staged loft between the ellipse, the base of the kind of cone shape, and then the top of the cone shape as well. So it's a series of steps, and then I'll obviously have some subtraction work to do afterwards. One thing I should say, when you go into Inventor, make sure you do have a project folder set up. Keep all your work in the same place. You'll see in mine, I've got things like my library parts. Something I should say is these might be provided as step files. I've got them as Inventor files because it means then the threads will be correct and consistent. I've also got my drawn template set up for a little bit later. So I'm going to create a new part. It should be standardmillimeter.ipt. When we load in, I want to try and keep things correct. I'm going to sketch probably from the plan view. So looking down on the XZ plane, I'm just going to rotate myself back to the normal view. Now with an ellipse, it is defined by a major and a minor axis, although in Inventor it will look at major and minor radiuses. So the major axis in this is 180. I'll just put in divided by 2, which would give me the radius. And same thing again, 150 for the minor axis, divided by 2 gives me that. So yeah, I mean, it's simple maths, I could put it in, but maybe this just makes it a little bit easier. So I said I was going to extrude this base up, and it was a distance of 12. I'm going to start a sketch on here and just project the geometry, which will give me the first bit of the loft. Let's just set current view as, yeah, that's fine. Or rather, should probably choose that one there. So this has given me the first bit of my loft. What I'm going to start doing is creating some planes. I'll just create a offset plane from that top surface, and it's a distance of 15. And then from that plane we have a distance of 20. So starting a sketch on the middle one, this will be the bottom of the cone section. So I'm going to draw a circle roughly where I want it to be. Its diameter is 40 and it is 40 away from the edge. Now I can't dimension from the edge there, there's no point. I could create something, or I know that this was 90 between here, so if this distance is 40, the distance left from point to point will be 50. Now it's not fully constrained yet because I can still move it up and down, so I'm just going to put a horizontal constraint to line those 2 points up. Finish my sketch and create the last little piece I have on top. And I'm going to project the geometry, and I'm going to project the point in the middle, and that gives me the position I need. Oh, I didn't want to finish that sketch. It gives me the position and I need to draw on the circle. The dimension is 20. Now I can loft between these two surfaces. So create a loft between the sketch 2 and sketch 3. I'm not going to do it as a full thing because then it will start to curve the features between it. So I'm going to do that as one loft and then loft again from sketch 3 to sketch 4. Oh, helps if I actually go into loft. So sketch 3 to sketch 4, and that creates the second stage. It's always good practice when you're done with the work planes to turn them off. And we should now have the fully modelled part, which is excellent. I say fully modelled part, we should have the overall shape of it. We now need to start putting in some of the subtractions. So I'm going to sketch on the top. I'm going to project the geometry of this and change it to construction. The reason for that is it gives me then a position to put my circle point on, or you could use a concentric circle constraint. Now, I'd already got the point, so I didn't really need it. But the dimension of this going down the middle is 8, and I can extrude that as a subtraction to the next surface. Underneath, I'm going to create a sketch on the bottom, project the geometry, and what I'm going to do is I'm going to offset that size. So with a distance of, so it's 140 minus the 170, which gives us 20, but it's only half the distance. If that's correct. No, sorry, I'm looking at two different things. It's 170 minus 80, so it's 5 between the two. And I can now subtract extrude that distance, or that shape up. And the depth of that is 8. I just want to check I actually put that in. No, I did not. Depth of that is 8. Now there's one little last bit. We've got the little hole on the back edge. There's a couple of different ways I could do this. I could sketch from my origin plane, from my YZ plane, and just take it all the way through the material. However, what I'm going to do is I'm going to create myself a tangential plane between that and the YZ plane and sketch directly on it. The circle itself is a diameter of 5. I assume this is for a little Y or something like that. And the distance from the bottom is 5 as well. I can now cut distance of next, and then that leaves me with it. And I'll just turn that visibility of that off. And that's me modelled the base piece. Shouldn't take too long. But yeah, extrusion and then 2 lofts. You could create that through a revolve or something else if you really wanted, but this is just a fairly quick way of doing it. Now the last little bit is I'm going to save this, and save it as what they give you. So they've called this the base, so let's call it the base as well. I'm going to create another new part, standardmillimeter.ipt, and we'll move on to the stem. Now the stem will be created through a sweep. However, it can't be done as one singular sweep. If we have a look at the drawing, we have different sizes that are on here. Now these sections are straight, so it could be created as a sweep, and these parts extruded. So yeah, I might sweep this part here and then extrude the last little bits. It could be done as a series of sweeps, as I say, or technically you could, I guess, extrude, and revolve round this point here to get the next bit, but that'd be a little bit stupid, to be perfectly honest. And again, trying to keep my plane orientation correct, I'm going to sketch the elevation, so the front view from the drawings that we've been given. This has been determined that that's the front view. So I'm going to just draw what we've got, and I'm going to use this as a reference sketch. So it's 45 up, the next distance is 185. Oops. undo that, and I'll put a arc on here, and I'm going to put some construction on this arc just because it'll help me to define it a little bit better. So these positions here. Now this should be perpendicular, and we should have a dimension between these points of 60. And the diameter of the arc is, rather the radius of the arc is 200. And I'm just going to then draw on the last two lines. And again, it should be perpendicular to the line that we've already got and positioned in. Just take construction off for those. Do an inline dimension of 35, and the last one is 20. So I'm going to finish this sketch, and I'm not going to directly do anything to it. I'm going to use this as a reference sketch, as I've said before. So I'm going to start at another 2D sketch in the same plane and just project the geometry of the bit that I'm going to sweep. So this vertical and this curved piece, and that last little stretch there, because they are all going to be the diameter 12 piece, and I'll do that in one single sweep. So I'll finish at that point, and I can turn the visibility of that sketch off just to make it a little bit easier. So what I've got my path for my sweep, what I want to do is create the profile. So I'm going to create a plane on the edge, so normal to the curve that I've got, and create another new sketch. And I want to create a diameter was 12, and then it has an internal diameter of 5. Now this isn't fully defined. It's saying it's got 2 dimensions needed, and that's because it's not picking up that. So all I'm going to do, it's not positioned right on the edge, so I'm just going to project the geometry of that point and then use a coincident constraint to bring that into the point, and that's now fully constrained. So at this stage I can provide my sweep. The profile that I want is this inner disk, and then along the path of the path of the stem. Okay, and I'll just turn the visibility off of the work plane, and I'll bring on the visibility of that first sketch that I had again. So I'm going to create the last little bit that's on the top here. I'm going to project the geometry of the inside circle, and then I'm going to project the size of the threaded part. So it's an M8 thread, so I'll have a diameter. I'll have a diameter of 8 as well. And now what we can do is we can extrude that profile out to a distance of the point on our sketch. And that's that part completed. And we'll do the same thing at the bottom underneath. So I'm going to start another 2D sketch on this surface. I'm going to project the geometry of the inside diameter. I'll then sketch from that point the diameter 8 edge. I can then go to extrude, select the inside profile, and go to the outer point of my line and finish my sketch. Sorry, I didn't want to finish my sketch, I wanted to finish my extrusion. There we go. Now, we've fully modelled it, we just need to add the threads on. I'm finished with the sketch though, and I'll just get rid of it. It's quite a good way of working with that one reference sketch. It means it's all updated from there, so I should be able to make changes quite quickly from that original sketch, should I have to. But I'm going to use the external thread tool. I'm going to select the face. It is a full length face, so that's fine. I'll change myself to an isometric profile. Now it's automatically picking up that this is an M8 thread with a pitch of 1.25. Now the pitch of this should match my nut that, or was it the, where's my document? Yeah, the locking nut that we've got on the bottom. I have checked it, and the pitch is the same. So happy with that. And again, I'll put a thread up in the top. Same thing as before. Make sure we choose isometric thread, make sure it's M8. It should do, it's picking up the size of it, but we'll keep it again with the pitch of the same position. And we can OK. And again, we're done, and this is the stem. Another new part, and we'll go on to make the boss. Now the boss is potentially a little bit tricky. I guess it depends largely how you start it. What I'm going to start with first though is creating the vertical plate. So I'm going to sketch from the top, and I guess I want to rotate this background, so I'm kind of again keeping the same orientations. The orientations don't matter so much, but it's quite helpful, and it just helps a little bit more when we are bringing together our model in assembly. Now I've just roughly drawn that profile that I'm going to extrude down. It is very rough at this stage though, but I can start making things more correct. You can see that doesn't quite go on the edge, so just bring it back together with a coincident constraint. I'm going to also put a coincident constraint between the center point. Now I can start adding dimensions. So the plate thickness is 1.5. The radius is 35, and because I made these equal, it adds up. Now at the moment, it's not fully defined because, well, A, the distance between the top and bottom hasn't been given, which is, I can see in the end elevation, that's 20. But even still at this stage, it's not fully defined because I can move it up and down. Use your constraints to bring this into the correct position. So from the midpoint of the line to the origin or the center of the circle should be horizontal. We can finish that sketch and extrude up. Now, to keep things a little bit easier later on for creating the cylindrical part coming in, I'm going to extrude in both directions, and that keeps my origin in the center of the part. And this has an overall distance of 35. Okay, so I want to sketch the circle somewhere out here and then extrude it until it meets this face. So the easiest way to do that would be to create an offset plane, and I've got a distance from this tangential edge out. So what I'm going to do is I'm going to create a tangential plane to that edge. So in reference to this plane, tangent on that edge, and I will then offset to a distance of 20 from the tangent. I'll just edit that dimension, and I'll go minus 20. Visibility off, visibility back on, turn the visibility of that off, and start my sketch on here. So as I say, the origin is now created in the right place, which gives me less work to do here. This has an outside diameter of 12, and I can extrude this distance to next. I'll leave the hole as different because I want to do this as a whole feature. So I'm going to use the hole tool. Now I'm going to use a concentric hole, and if I select the plane, which it's asking me, and then the concentric reference, which is the outside edge, it puts it perfectly in the middle. This will be a threaded part, and again an isometric profile thread, and this has a size of 8. And again, I'm just keeping the pitch the same for all of them, and it's a full depth thread. Remember, when you are creating internal threads like this one, you must use the hole tool. Okay, so we've got two little holes going at the top. Now, I've already created a plane that's going to help at this stage. Again, I could do it off my origin planes and make big extrusions to cut out and cut all the way, but I'm just going to create it on the one that I've got, which makes it a little bit neater. They have a size of 5, and the dimension here at this stage says it's 25 between them. Now this is a fairly bad dimension, to be perfectly honest, because I'm having to make an assumption that the distance above is the same as the distance below. So 25 divided by 2 gives me my position. As I say, I'm not particularly fond of it because I'm making assumptions. Change that to a horizontal constraint. I never understand sometimes the difference it makes. But yeah, okay. So that's now fully positioned, and I'm going to cut that to a distance of next, and it just cuts out the position that I want. Now I have only done one. The reason for that is I can very quickly mirror that feature across the horizontal plane to put it in position. And that's us done. So again, use the correct name, we'll call it boss. Now the last thing is the shade itself, or the last modeled part. Let me find my sheet for that one. Okay, so looking at this, it is probably easiest to create with a revolution with a fillet on the top and then subtract extrude the cut section on the bottom. So it technically won't really matter what plane I go in because it will be symmetrical all the way around. Whenever I'm doing revolutions, I always start with a center line in the middle. I'm just going to put the middle point of the center line on the middle point of the line, and it just stops it from moving, but I still have control to maybe resize this if I need. But now I just want to draw roughly the shape of what I want. And I can start putting the dimensions on. So the height of this bottom piece here was 130. Now the top section to the fillet is 35, and then it's 15 to the top. And again, I know I can do it in my head, but 35 plus 15 just saves potentially going wrong. And we've got a couple more dimensions actually from this outer point to the center point. Now this is the reason why I always use center marks, is it gives me a diameter dimension, which is quite useful because I can just instantly input it. Now obviously this is still too thick, and again, another bad dimension. What they've given us is the internal size. We know it's got a wall thickness of 2, so it's going to have 2 plus 2 and the gap in the middle. So the gap is the 66 plus the 2 plus the 2 means it has an overall size of 70. We can then revolve this part, and it's automatically picking up my axis and my profile, and we can hit OK. Now I should do the fillet first, because you'll see from the drawing there's an internal fillet that matches it. So if I do the fillet first, it means when I shell the object next to remove all the interior with a wall thickness of 2, and I remove this face, you can see it matches the same profile on the inside, and we are left with this. Okay, I'm going to move on to the next stage, which is on the top, and we've got like little, I guess, holes to allow the heat to dissipate, and they've given us a pitch center diameter, so we can put on the dimension of 5, and the diameter is half the radius, so it's a diameter of 30, so it'll be 15. And I'm just going to put a horizontal constraint. Again, it's not horizontal because I'm currently on the top, as there we go. I'm going to put a vertical constraint in that case. If I subtract extrude to next, and then get my little cut. I'm then going to make an array, so a circular array of that pattern. I always do it as a feature because it means I then don't have to select multiple profiles. So I will make an array of this feature on the axis. Why is it not hovering up? I can just select that, but there we go. It's on the y-axis. It tells us that there's 8 holes, so type in 8, and then I get my array created. So on the elevation, so my front view, which is over here, I should have a triangular section created. So I'm going to start a sketch on the XY plane. I'm just going to cut this in half to make it a little bit easier, and I'm going to project um, the geometry that I've got. So I'm going to be cutting from that outer edge here. Just change that to construction, and I'm going to sketch from the outermost point to that corner up to somewhere on that line. And now all we should need is a angle dimension, and I believe that's 20. So with this, I've taken those points out, and it very quickly allows me to do it. With this, it's going to be a subtraction, but again, because I'm in the middle of the shape, I need to make sure it goes both ways. And I'm just going to go all, because there's nothing else in this shape, and get rid of it. And that leaves me with this. Now there's one last thing, which is adding in the little details here. So I'm going to create myself a little tangential work plane. So in reference to that, on that point there, I'm going to create a sketch. Now it should be noted that the origin point that's giving me the sketch is at the bottom, so bear that in mind when you're drawing things up here. So I've got two threaded parts, which we'll do with holes later. So in this sketch, all I'm going to do is the diameter 5 hole in the middle. So the 5 is positioned there, and it is 12.5 above the other one, which is 5 up from that edge. So I'm going to project the geometry of this point here. Just make that construction and give me a dimension between those. So it was the 12.5 plus the 5. There we go. Now it's not fully constrained because I imagine I can move it left and right. So if I put in a constraint between the two of them, just locks it into place. I can then subtract that part to next, and it takes out where I want. So I'm going to create a sketch now on here to do the other parts. Because I'm going to create a whole feature, all I'm going to create is 2 points. So a point above and a point below. Now we know the distance between these, because it's a bit that lines up with the boss, is 25, and it should be evenly spaced from those points. Or again, I could project the geometry of this and do a distance of 5. If I just bring them all into alignment, so all the points are directly above each other, and it won't be so wonky. So I've now positioned the 2 points. So when I now go to the hole tool, using the placement from Sketch, last time we used concentric, but from Sketch it picks up the points automatically, and it's going to be another tapped hole. Change it into an isometric thread. The classification of these is, well, these are M4s, size of M4. With this, again, it's a smaller thread, so it's got a smaller pitch. I'll just keep it at 0.7, which will match my other one. Something that should be noticed is it's currently going through all. So rather than through all, I'm just going to choose a distance, and it should be distance of, it's actually what, 2, but it's on a curved surface, so it's long enough to make it not touch the back, but through the hole. And I'll just turn the visibility of that off. So I've now modelled the threads in the top. I've got the ray at the top as well, and I've got my cut section. So I'm going to just save this now as shade. And that's me modelled the 4 parts that I need. So the second last thing I guess I need to do is create a assembly drawing. So standard millimeter.iam. Always start with the bit that everything connects to. So in this case, it's going to be the base. Right click, grounded at origin for the first piece, and that means the first one is kind of locked in place. So I'm going to start adding certain things in. So I'm going to place next the stem. And as I said, because I've created these in the same orientation, it comes in quite nicely, which should make a lot of this a fair bit easier. So I'm going to use a center axis constraint, put that in, and I need to mate the top and the bottom of these surfaces. Now at the moment this will still fully rotate. So what I'm going to do is I'm going to mate the origins together. So the origin of my stem should match, the XY plane should match the one that is there because I've created. If it doesn't match, then you can use other planes to put in, but my XY and my XY, rather I didn't want that to happen. Constrain, is it my XY? Yeah, it's my XY. I want to mate my XY and my XY together. We'll flip it around the other way to an alignment, which keeps everything in the correct order. So the next thing that we're going to put in is the boss. So I'm going to place in the boss. And it's the same sort of thing. So we have the center axis onto the center axis. We then want to constrain or rather mate the two surfaces together. And again, what we'll do is we'll make use of the origin planes that we have, that we should be able to put the XY and the XY together. And that should stop it from rotating. One more thing, we'll place in the shade. Now the shade might be a little problematic. In fact, no, that should be fine. So what I'm going to do first of all is I'm going to constrain the whole. I always think about it as how would I manually actually assemble this together. So that now has a constraint onto it, and I'm going to put the same center axis constraint between the bottom two, and then I can use a tangential constraint on the inside to put those two surfaces together. Yeah, so with a tangential constraint, actually, it's not so bad. Okay, so that's us very quickly assembled all the parts we've done. It's always a good idea to try and click them, drag them, see if there's any movement. The only things to add now are the given parts. So it's the M4. Now these might be given to you as a step file or an inventor file. If it's a step file, you'd obviously have to make use of place from imported CAD files and bring it in. The problem with some of the step files is they might not come in with the threaded information, which potentially is an issue later on for some of the drawing work. Now we want this to again be center axis into this position, but what I'm going to do is make it tangential to that surface. Now in here, I know that I made earlier, I'm just going to minimize all these again. I know in the boss I made a work plane that was tangential to that surface, so I'm just going to turn the visibility of that on, and I'm going to mate this surface and the inside lip of that, or rather, I don't need to go in as alignment. It's because the plane, it's technically the back of the plane. And constrain again, center axis onto the center axis, apply, and we'll align now the back of the plane with the surface in there. Now they can still rotate. I could stop the rotation, I guess would be better practice. What you don't want to happen is essentially to come into your drawing at a weird angle. You want to, where possible, to have it come in kind of true angles, so in proper orthographic positioning. The easy way to probably do that would be to add in some angle constraints between that plane and that outer edge, that plane and that outer edge, and that should mean that it can't move. So just flick the visibility of that off. So that's two of them. We've still got the washer and the locking nut to put on. So I'll place in the locking nut, and also place in a damn washer. These shouldn't be tricky in any way, but if we put a center axis between the two, and then we mate the two surfaces together, do the same thing for the last piece, center axis, and then mate the two surfaces together. And that is us fully assembled. So save this, and I'll call it full. Yeah, that's it fully assembled. Now the last bit of modelling we need to do is the exploded view. So we'll do that as a presentation file. So file, new, standard millimeter.ipn. Want to load in the full assembly. Ignore all the animation stuff. Whilst it's, yeah, I would usually get you to make sure it goes in the right order and everything else. It's not really necessary. Okay, so if I was disassembling this, we'd start pulling everything out in the way that we go. So I'm going to tweak the components first of all. I'm going to have everything come out. Now, one thing to be wary of, in some instances you might need to go between local and world, because later on we want to go in the direction of the way these are positioned. It might be needed to distinguish between the two of them. Okay, so it needs to go up enough so that it is out of the, or it's no longer overlapping from the position that it came in. It should always go straight from the direction of its position. So I've moved everything up out of that position. I'll deal with all the trails later, so don't worry too much about that. And much like the same before, I'd essentially disassemble. So the next two things that I would take apart are these two machine screws that we've got in there. So I'll just make them go out the back. Well, I accidentally clicked enough to position them. Yeah, that's fine, and nothing's going to be hidden. So I'll then start moving this out, and this might be where the issue is. Yeah, so it's automatically picking up local, which is worked out fine, but sometimes you might need to go between local and world to get the parts to come out in the right line. So as I say, all enough. So for that boss is no longer overlapping the threaded part, and I'll just do the same thing for the lampshade, and that's done. Don't forget about the nut and washer below. So we'll just hit X. I don't know what I tweaked there, and undo that. Fat fingers today. Bring that down. I'll just pop myself up into my home view. So I need to go down enough to see it, so I wouldn't see that washer in that position. And then one last tweak to bring the nut down and off. There we go. And I find it easier at this stage to deal with the trails. Yeah, rather than individually doing it. I find it just a little bit faster. Would certainly be faster if I start selected group rather than individual. And there we go. So that's the full exploded view. As I say, make sure that nothing's overlapping. Make sure it's coming straight in line from the position of where it came from. And I always take the process of just how I would assemble it or disassemble it. As I say, the order is not necessarily correct because really, before I could have pulled that, I would have exploded those down. But for the sake of this, it doesn't really matter. What we are only interested in is a snapshot view. So add your snapshot view onto the side, and that means then when you come to create your drawings, it'll be all loaded in. So I'm just going to save that. So we have our exploded assembly. and that's us created everything that we need for modeling. So we created the base, the stem, the boss, the shade. We assembled them together with our library parts, and then also created an exploded view. So in the next video, we'll look at creating the drawings. Whilst a bit of time is spent here, it's important to remember I've actually gained no marks so far. So despite all this work, I've not gained any marks. It is only the drawings that pick things up. When you are modelling, go through the processes. Try and spot what modelling techniques are going to be best to use. It, as I talked about when we're modelling this, technically I could have created that and there was a revolve, but it'd be more time consuming than creating as a loft. So try and do things efficiently. Maybe you've picked up some new tips, certainly with the creation of the stem, using that reference sketch to pick it up can make things a little bit easier for us. Hopefully that helps, and hopefully this supports you doing your final assignment. Thanks for watching.